split 唔到喎，HDMI 你要撈翻過嚟。
撈唔撈到翻過嚟啊？有冇 extension 啊？有，但係試過頭先冇試過。
something in command line. And also, how many of you work with a command line tool called AWK, AWK? Okay, okay. Okay, cool. Okay, maybe another question. How many of you work with abstract syntax tree traversing and like code understanding in Python? Okay. So let's keep some demo then. We'll talk more. Yeah, by the way, the presentation is available on GitHub. So if you find my profile at Pavlov, Pavlov 99. So that's profile, and then there is a repository of presentations. And they have PyCon. So you could see the presentation, and all the examples are there with README. Just in case we would not have anything there. Let me also try to build a bit on top of Benny's presentation. So the previous one was about energy data analysis, right, and some kind of streaming data analysis. And the idea was, okay, well, we could use LSTM, we could use Keras, we could use CNN, but essentially the idea is that we work with some streaming data. So this talk would be somehow related to columnar data analysis and columnar data processing, especially if data is big. Like very big. Like you need to have Hadoop. You could not upload to memory, and maybe even database is not enough. It's not like not enough, but not reasonable. And I'll also would show some example of for kind of stock trading data, which is not about stock. It's just like, okay, well, gimmick. Okay. So we're back to the first one, right? We're back to the first, right? So I will be talking about two repositories. One repository is presentations. Actually, if you go to the home page, there are like the most starred one, and the presentation should be in one of them. And within that, there are multiple folders. So that should be 217.11.05 PyCon. And the other repository I'll be talking about is also in the same profile called Tab Tools. Tab TAB tools. Okay, so get a command to start. Okay, so let's start. So basically, let me just a bit introduce myself. My name is Kirill, and I'm a technical recruiter in a company called Terminal One. So if anyone needs find candidates, just let me know. I'm not a traditional recruiter. My background is in tech. This is about 10 years. I started in a company called Yandex, a search engine company back to Russia. And then some startups here, and previous to that, I was in data science Asia Miles. And first of all, let me thank all of the organizers. Actually, yeah, despite any issues, guys committed to the organization of the conference. So thanks, guys. And what this talk is going to be about. So this talk would be about command line experience boosting. with Python. Actually, it would be about Python and it would be about AWK. I'll try to talk more about Python and see what we could do with that. And there will be a lot of examples. Probably we would skip just because of time. Everything is available online. Just mentioned to you in GitHub. And we would have some example with stock trading data analysis. But again, this is just gimmick. Yeah, think about what tool can do. And yeah, let's just skip this part. So start with background. So basically, I mentioned to you that I started my career in a company called Yandex. It's a search engine company in Russia. They have about 100 million users, unique users per day. And it was about 2010, so Hadoop wasn't that popular. And I was working in ads department, so advertisement. And what's about ads? Actually, in ads department, you would have a lot of data, just like a lot of data, right? And we have about 10 gigs archived daily data about ads. So timestamp, some IDs. And idea is that we wanted to perform some very simple operations on that. Maybe joins, group by, sum to columns, something like that, maybe filtering. And every single time we wanted to do operation once. We actually didn't want to do it multiple times, just once. And seems to upload data to database wasn't the solution, because like, why do you need to upload, calculate, and then remove? I guess nowadays is better to do such stuff with some serverless applications. Some guys talk about that before. But let me talk about solution we actually made in 2010. So it was about releasing set of command line tools, essentially wrappers for Unix core utils. And as example, I want to just show you a task which might appear. So I just get a Higgs boson data from UCI machine learning repository. Nothing specific about that, just some random columns. But what's good about that is that it has 11 million objects, and it has 28 attributes. Doesn't matter which attributes, just some like signal yes, signal no, and some lepton data and something like that. And it's about 7.5 gigs unarchived. It's not that big, but to have it bigger, it would take forever to show a demo here. That's a problem with big data. And I found 3 questions, which we might have all the time once we work with data. Just simple questions, just random questions, okay? So what's the maximum value of one of the columns, lepton eta? What's the average value of one column by class? There are only 2 classes, 0 and 1. And the other idea is that could we filter the whole data set with some parameters? There would be about 9 mil objects, and sort, right? And just think about like, how would you do that if you would have this kind of tasks? So okay, we're in PyCon, right? So okay, let's use pandas and Python. So we use in-memory calculation. I also investigated some database, so I use Postgres, and the other one with AWK. Demo time. Okay, so let me try. Oh. Hello. Hello. Hear me, right? Okay. I just show Python. I wouldn't show Postgres here. Just because of data. So so basically there is a Higgs boson data. That's Higgs CSV, the big one. So this one. And let me run the script. It actually would take some time to run. So while it takes some time, let me just walk you through that. Yeah, also why I like command line is because you don't have a lot of lines there to write, so you naturally modularize your functions. That's coming back to Benny's talk. So basically, line by line, what it does. So we have some pandas, and then we open file. Actually, that's header, just names of columns. Main function goes here. So we read data from CSV with pandas. All of you done that. And again, this data has 11 million columns, so it actually takes time to load to memory. And once we have data in memory, that's super easy, right? So you just say, okay, data lepton eta max, so and we answer the first question, and then the second question, okay, we just group by signal, and then we have our average data for lepton phi. And if we need to output data, so the interface actually of pandas is quite nice. So like, it's readable, we understand what's going on. What is the difficult part of that? Well, the difficult part is, I guess, is that it just takes time, right? So it's still calculating. Yeah. In fact, when you work with bigger data, so for example, recent experience in Asia Miles, like you pretty much cannot use that because you have a lot of customers. You could not possibly load data in the memory. And then it's possible to have some tricks, but at some point of time you already try every single solution, you work on the feature engineering. So you work on the feature engineering and data doesn't fit memory again, right? So so basically that's a solution with pandas. I have one with SQL. Let me just show you SQL part. So SQL is super easy, right? So you just like SQL readable. Obviously, positive part is that it's easy to read. Negative part is actually, if you think about that, you integrate database, you integrate a table.
How many rows you need on this?
Sorry?
How many rows for
So that's 11 million rows, and you have 28 columns, right? So it's like pushing 7.5 gigs of data to the Python. And actually, the calculation itself is nice. The problem is that you spend most of the time just creating database and uploading data to database. And a second, once you download from database, it just takes all the time. And in fact, you could solve all problems even like faster than you do the first one. It's actually not about being fast. So let's do some reality check. If you work on your personal computer, you probably never experience those problems. But if you work in some corporates, there are 2 points. So first, you don't have sudo access to on server usually. So you don't have database, okay? No one could create database, no one would create database for you, no one would maintain database for you, right? So that's the first thing. Second thing, sometimes you don't even have internet access to on a server, right? It's just like some firewall and like you could do whenever you like. So that's why companies like to use Java jars or just copy C++ code and compile on a server, but you probably would never use Node.js on a server, right? Because you just need to pull all the packages and you could not just copy and paste the code because there are like 2,000 packages, like what to do. So Python is the same. Anaconda somehow solves that, but not really. And of course, there is no way to have like some R, MATLAB, or Excel, right, on the server. So solution, okay, get better at command line tools, right? So use what we have. Let me just have some intro into AWK. What is that? So basically, AWK is a language for streaming columnar data processing. So every single word here is important. So there's streaming, there are columns, and there is a data, right? And that's pretty much standard tool for Unix like OS. And the actual AWK is outdated, so every time I talk about AWK, I mean 2 things. Either this GAWK, so this GNU version, or I would call it MAWK probably, MAWK. And the first one is faster, while GNU version is more flexible. They have a bit more functions. And basically, AWK is super simple, right? For those who've been to JSON RPC talk yesterday, so you could think that I like simplicity. So it has pretty much 2 free data structures, but the most powerful one is a so-called associative array, which is similar to hash maps to those of you who work with some Perl or maybe PHP. So or you could think about dictionary in Python, but essentially in Python dictionary you could put as a key only immutable object, right? You could not put mutable object. While for AWK, like there is no such concept. You just use whenever you like. You could put anything as a key, and also, there are some built-in variables, so you could use $sign and name of column, number of column, and also you could use number of lines, current number of lines, and current number of columns. So the other interesting part is that it does not require you to use any declaration, so you could just use variable equals something, or if variable exists. So you don't need to check whether variable exists, you don't need to define its type, you just don't need to do anything. And from my point of view, it's kind of hipster friendly language. It's kind of Ruby-ish language. And I think I also have some examples. Let me just check of time. Okay. So let me show it how it works. So basically, for example, we would use PyCon. So I just created PyCon schedule here. So oh, by the way, we finished with Python, right? So you could see it took us 100 seconds to load and 20 seconds to calculate. The other 2 is 120 seconds overall. So basically what I have here, and then I have that PyCon schedule CSV. So it looks like that. What's bad about that? Like, it's super hard to read, right? So that's why CSV is not good. So let's use TSV, tab separated files. So tab tools work with TSV because you could read it. So it looks like that. So basically we have number of day, we have day, so first or second, we have time slot, we have venue, and we have speaker, and we have title. And the first question here is that how many speakers are there overall in PyCon, right? So I guess let me just go over the code with AWK and then demo with with tab tools. So basically with AWK here, wow. Yeah, so what we do is that we need to select a column, right? Okay, I could demo it. So for AWK, we need to provide information about separator, so as a field delimiter, and then we need to write a program, which is essentially if we have speaker, but speaker is a column number 4, right? Then print speaker. So that we have our speakers, but obviously I had a hat right here. So those are all of the speakers, but we want to have unique speakers, so we use sort first, so to make sure that they are sorted, and then we use unique, and then actually the speaker at the end is some word we don't want. So let's just count the number of lines, right? So we have 16, but we have a speaker word here, so actually we have 15 speakers. So what's the problem, you could see? The problem is that no one cares about this column number 4, right? Like you need to count if you have 20 columns or 30 columns, like in Higgs boson you have 28, like you would not want to calculate those columns. And in fact, that's why these tab tools appeared. So basically tab tools allows you to define header for files. So that's Python, it's Python script. I would be talking about how it works. But essentially, what we could do, we could use the same Python schedule, TSV, and then we could use column speaker, and that's it, right? But we want to filter those columns which work, right? So we could provide filtering expression, which is -f, and actually, in fact, it should be just speaker, so we have all of them here. And the rest is quite simple, right? So we also need to sort and we also need to unique. But the thing is that the whole functionality become very simple. Like you don't need to think about column number 4, column number 20, and so on. And the speed is the same here. Okay, let me skip other topics, but basically one of that is that what's the most popular word in PyCon? So the thing is that you don't really need to have the same number of columns in every single row. So that means that you could process text files. You could just see all of the words separated by space. And guess what is the most popular word in PyCon topics? Python, yeah. How could have guessed? Actually, the second most popular is 2, so probably Python 2, but I'm not sure. I hope everyone using Python 3 already. Yeah, and okay, maybe let's skip for that as well. Here, idea is that we would like to have some speakers who would have talks individually. So that means that there is no talk in the other audience, right? And the idea is that we need to group by, and we need to filter. And actually, it's kind of SQL type of command. And actually, tab tools also allows to do that. So you could see like from here, it is tgrp, so it's also tab tools. And it allows to have key, and then allows to have some grouping expression. So here is just very, very simple. So if you have multiple days, just get first day because it's the same. If you have multiple time slots, just get the first one. Let me skip it. So it's on example. So if you go to GitHub, you could try it on yourself. Sorry guys, I think I missed one slide about the performance. But let me tell about that. So the first about the tab tools, what's cool about that is that we have, say, comma separated files or tab separated files, and we would like to work fast with them. So tab tools allows to work with those files faster than pandas. Well, it's kind of faster. If you have a lot of operations, it's slower. if time to load to memory is so long, like 100 seconds, you might process data from disk way faster. And the idea to do that is that we define headers for files, such as here. So for example, for stock data, some data, open, high, low, close, and volume. And then tabtools would understand. So tabtools is a Python script, essentially. So what it does, it parses the first header row, understands the column context, and then creates the command line program which would be executed on a stream of data. I'll show some more examples there. But essentially, the whole procedure, how to merge files, how to filter files, is managed by Python, not by command line, of course, because command line is like, you don't want to write scripts in command line. And all the heavy lifting goes to awk and grp. And why it happens this way? Again, so based on own experience from Yandex, we had quite a lot of files actually, and quite big files. And we try Python, we try Cython, we try PyPy, and then there is another tool called Shetskin, which allows you to convert Python to C code, and then compile C code and execute that, and it's still slower. So actually, command line tools are super fast. So yeah, if you haven't tried them, take a look. And the other thing, it introduces the number 5 here is tpretty and tplot. So it's just syntactic sugar to see data in command line. But basically, let me just go a bit through the architecture of that, because I realized that last time I didn't tell about that well. So basically, there is a concept of file, and file could be of two types: so regular file or stream file. So regular file is just you open it and read, and stream file is std in, so you couldn't read twice. You could not seek in a file. Like you read first line, you could not seek to the first line and read first line again. So you need to write some wrappers there, and essentially multiple files form file list. You could think about it as just a range of file descriptors from which you could read. And file list manages the whole file concept. What it also does is that reads all the headers of every single input file, and based on that, merges them and creates arguments for a command line tool. Right? So it's kind of meta program for command line tool. Let me go again. So those three squares here. So the first, we have a header. We convert columns to column numbers because all of the command line tools work with column numbers. And then if we use awk, we generate awk command, awk program, and then we execute this command with the stream from previous files. Okay? Let me show you an example. So let's say we have file 1, we just got it, and then we send to sort function, which has a key. So normal sort function would have a key like 1, 2, 3. So you need to actually specify column number. While here you could just say field. Why is that good? It's because if you work with feature generation, then you would have a lot of columns. You might have several thousand columns, and it would still work quite well. And essentially, based on those files, file list here merges them, merges only first line of those files, and creates header. Based on that header, it would substitute this field 1 with actual 1. And execute sort, which is command line sort, on that. So this thing works way better, way faster than pandas, because you don't need to load data, you just read it from disk. The second thing here is that it's important to understand how awk program works. So I think Python actually on the left side is not that interesting. So basically there are just bunch of statements, so begin statement, some body, and usually you just use body statements. And the streaming program would add statement one by one, while group program would create some grouping expression. It's actually very similar to Python group by. So if anyone read source code for group by of Python, then it's like pretty much the same. And there is a concept of expression. So think about it this way: you have a mini program. Like you remember, we use those keys for in this example in 1.2, right? So we use -o speaker. Actually, speaker is a mini program, and here filtering is also a mini program. So what it does, it parses those mini programs and generates awk expressions based on them. So how to parse expressions? So essentially, you could use Python in command line, like straight away. You don't want to use Python directly because it's slow. But essentially, it uses AST not transformer, so that's a standard Python library. So it goes through every single expression, parses it, and outputs awk program. You could think about it as a language translation from Python to awk, right? And the very base one would work with assign, with some function call, with expression. If you could use if, you couldn't use for loop so far. Actually, once I look at it, I realize, okay, well, like it's so good, but could it be better? And I thought about extending it. So basically, for group expression, you need to know how to work with group of data, right? Like how to write aggregators. But again, you need to write aggregators in awk. So you need to translate aggregator from Python to aggregator in awk. And those are very, very simple. So first, last, minimum, maximum, sum, like obviously stock trading data. And for stream expression, just implemented sum, average, exponential moving average, and minima and max. But think about it. Actually, I think I have a next slide here. I have a homework, actually. Like, for those of you who are very curious, just think about the three concepts. So imagine you have a stream of data, just 1, 2, 3, 4, 5, just like infinite stream of data. And your task is to calculate average. So it's just very, very simple average, right? So average of 1 is 1, average of first two elements is 1.5, right? And average of first 3 is 2. Nothing hard here. But how about running average? So if you have a window, right? Like, how do you implement that? So, and the other thing, if you have running maximum, how do you implement running maximum? It's not associative function. You couldn't just subtract and add. So it actually requires DAC usage, double-ended queue, and of course awk doesn't have double-ended queue. So there is a module which simulates double-ended queue with for awk associative arrays. So if you're curious, yeah, just feel free to read source code for that. And essentially what's going on there is that based on file list and based on that header, we create a context of every single expression. What is context? We basically map field into field number. And then based on Python arguments, we create the program, right, based on input parameters. What do we have at the end? So we have streaming expression, which actually not that trivial to implement. Actually, I'm not sure that Python pandas has it. I think they did relatively recently introduce that. We have aggregators, modules, and at the end, every single module is very, very self-contained. So essentially, think about it as just a bunch of Python files concatenated together. Every single file is about 1,000 lines of code, and there are no dependencies, like, at all. You don't even need to install it. You just copy it and paste to your server, right? Because remember, you don't have pip on your server, right? PIP. So, the other thing which is also important is that they are portable, so you could work with Python 2.7 or for free, no matter what Python you have on your server. No configuration, straight away, works faster than Python, Cython, Perl, even with shad skin. And yeah, so that's actually the table, the comparison of Python, Postgres, and different awk and tab tools. So while there is some room actually to improve certain functionality, but essentially for those three questions, as you could see, the last one, tab tools, actually works faster. So here in the demo we had 100 seconds for Python, but like, it really depends what you have in the background. And what's interesting about that? We didn't need to use anything. We didn't need to use pandas. It just straight away from command line works faster, and actually you end up writing less code. I want to show you another example here. So actually this presentation was originally given at CodeConf, so that's why that's about stock data analysis of Credit Suisse. And let's just go to example straight away. Demo time. So basically for this task, I had file cs.tsv, which has stock data from 1995. And remember I told you about tplot, because sometimes it's harder to read it, right? The columns are not aligned. So there is a tool called tpretty, which does this thing. Yep, and essentially what it does, it could calculate metrics. Anyone trading stocks here? Okay. um, okay. So basically, it allows to calculate metrics, but so basically how it works, right? So it has a file, so we could cut from that file, and we could calculate metrics. So basically, every single line here is every metric, right? So for example, we would like to calculate mean average, right? So actually, let me just copy some files from here. So for example, there is a function tail. So yeah, so basically, yeah, we just calculated mean average over the window of 200. But think about that. So we actually pass parameter to that function from the command line, right? So let's say we would like to calculate mean average with like window 2, right? So we calculate it. So it's supposed to be that, for example, this value 1601 should be mean between, should be just this value, right? But this value should, okay, could check how it works. But basically, the idea is that the whole metric, whole indicator, was done with, we could count symbols of, right? It's not even multiple lines in one line. It's actually quite simple. And then basically there is a bunch of indicators which people calculate for stock data. So we could calculate all of them. Okay, is it fast? Well, actually, we are not talking about speed. The data size is so small. So basically, I executed that script, which I just shown with this data, and redirected flow to metrics.csv. Okay, so now we have metrics. Couldn't read, right? Just like so many columns. So that's why we need to have visualization. So yesterday it was a talk about matplotlib, so you could use different visualization tools. So we're talking about command line. So guess what? We use gnuplot. So yeah, it's actually quite powerful. But so let me see the shortcut here. So basically, I wanted to make chart which is similar to charted stock charts, which is the tool which provides charts. They actually provide way more than any like Hong Kong like if you go to like HSBC or like interactive brokers or like A stocks, they provide a lot, but they don't provide that much. I mean, you could have more. So the idea was, okay, could I validate the data using, say, New York Stock Exchange stock and stock charts and simulate that to Hong Kong stock? So, and then we plot. So then we have this picture. Which looks, okay, it looks the same. It looks a bit dirty, okay, that's true. But like message there, you get the same. And overall, there are maybe 100 lines of code, like all the plotting lines, plotting code, calculation code, like everything is probably under 100 lines. And obviously, it's relatively fast and easy. So I guess that's it. Yeah, that's I'm on time. Thank you very much, guys. Again, so that's my context. Yep.
So, just a comment. You can still have a bit of cache on the server. You can bootstrap your own warehouse. So
Yes. You can set up your own. Is possible. Yeah. In fact, that's we actually did it before in startup company. It's possible. What I see, in fact, what happens is that like on some management side, they say, okay, well, no way. Like we need to check the package. We need to make sure that there are no vulnerabilities in packages. But yeah, I think it's possible. Yeah, thanks, Dennis, for comment.
So the normal expression here, you use all the CSV files. They are pretty hard to any the data processing framework.
Yeah.
So we have HD5. We have other standards that are made directly. They're written in C++. They blazingly fast. So
Yeah, correct. So I have two commands here. So one is that there is a project called Apache Arrow, and they try to have a bridge between those formats. So that's the first. Second, actually, if you're talking about HDF5, like those Hadoop type of formats or like big data type of formats, actually, it really depends on the task. Because if you work directly with the data, so you store the data and you read it a lot, so maybe you don't change, but you have access to the data a lot, then I would advise to use those formats. That's true. So this tool is rather suitable for situation once you need to read data once, maybe process it, just dump it somewhere, and you don't need previous files at all. Or the other use case I found is that if you want to have some handy tools on your server, and you just copy and paste those files. Yeah, actually, I could probably show them. So you could see that they are in my local bin. Yeah, so it's essentially just one file. It's just concatenation of like all the stuff. So for example, like this one goes from 6, this one goes from utils, and like this goes from base. Yeah, so it's very, very simple. Yeah. So come back. If you would like to have production system, this probably is not the best tool. If you want to have proof of concept, that's actually okay tool. That's kind of workaround which would work maybe in 80% of time, but don't over rely on that. Yep. Thanks. Actually, that's very, very good question, because so most of the stuff. Okay, so if you directly use command line tools, right? So I assume that they would work. So I would not debug something which was working for like 20 years. For wrappers, there are unit tests. So actually, they're written in Python. There is some integration testing. Actually, like frankly speaking, like at this stage, I just test in Bash. So it's just the integration testing in Bash. It's indeed hard. In fact, it has some debug mode. Sorry, could I show one more? Okay, so probably it's hard to see here in the screen, but essentially it has debug option, so it could print awk program which it generates, but then like is an readable thing, right? So that's why you don't want to write awk, right? You want to write Python, right? But actually for smaller commands, yeah, I mean it's kind of try and learn debug, so it's debugging, is not testing. Testing, yeah, unit tests and integration tests in Bash. I think I'm right.
Okay, thank you, Kirill.
Thanks, everyone.
We will now have a short break till 3:30, and the next session is recurrent neural networks in Python.